Hello and welcome to the first part of my C series. And in this series we're gonna look at the concept of memory, pointers, references and all that good stuff in C. And this tutorial won't be aimed at beginners to general programming. This will be more of a power user sort of tutorial who already know a bit about programming but don't know much about C or low-level memory stuff. And memory is an imperative aspect to C. If you don't know about memory, you can't build any even remotely complex program. So alright, let's begin. First let's edit a file called main.c, because that's the convention. And in C we generally include standard io.h, which is just for input and output. It allows users to input text to the program and for the program to output text to the user with printf. So it starts with a main function, much like any other non-interpreted programming language. And the main function has an integer return type. It returns a 0 if everything's okay, and anything greater than a 0 if everything is bad. It also has two arguments, so integer argc and a character pointer to a pointer argv for argument vector. This is just command line arguments to the executable. You don't need to know about this, I'll explain this in this video. Alright, so how do we use memory in C? Let's start off with a very simple integer. So we're going to call this number. And we're going to set this to 0. And the function that we need from standard io.h is printf. And that just prints out a format string, and format string, if you don't know, is just a string, which is that's the value of number, and then a format character, %d for integer in this case, and then arguments, which are the whatever is gonna go substituting into this. So in this case this will be substituted with the value of number, which is 0, and we're gonna print a new line after that as well because it looks better. Right, now let's open up a terminal and scale it down a bit. And GCC, which is the C compiler, the GNU C compiler, my favorite C compiler, main.c -o main, and that just compiles the main.c C file into main, the executable. And now we have an executable called main. If we run it, we'll get the expected result. Value of number is 0. So that's just basic variables. Anyone who has ever programmed in their life knows about this stuff. Now, this is a very impractical example. No one will ever want to do this with an integer, but it's very important for other types of data, which I'll show you right after this basic demonstration. So if we create this void function called change value, and a void just means it returns nothing, and the arguments to this will be integer number and integer new number, and it's gonna set number to new number. Now once again, very impractical example, and anyone who has ever programmed will know that the value of number will not change. So let's see if that holds true, and it does. So this is just an automation thing that compiles that, runs it instantly. The value of number is 0. Now this is to be expected. Oh, we didn't even call the function. Well, I'm stupid. but I'm guessing you'll know what will happen. So number, and let's just say 46. It's still 0. Now, however, here's where memory comes in. So many people make a big deal out of pointers in C, like make 20-minute videos on how to use a single pointer, and it's like a 4-episode series on pointers, and it's dead boring. I'll explain this in 5 minutes. So, there are three things you need to know. Reference, a pointer, and a dereference. Very simple. So, we want to actually change the value of number. And how would we do that? So, remember, variables aren't some special case in programming, right? They're just a value somewhere in memory, in RAM. And any value in RAM has a address. Obviously, RAM is all indexed. And in C, we're able to get the address of that number. So in this case, when we're passing a number into the function, what it's doing is it's copying the value and it's putting it into the number variable, which is in the scope of this function. So it's not editing this variable at all. It's editing a completely different variable in a completely different place in memory. However, to get the memory address of a variable, we use the ampersand, which is called a reference. So now this is a reference to number. We're not passing in the value of number, we're not passing in 0, we're passing in the memory address at which this zero is stored. Now, we have to adjust the change value function. So, this is no longer an integer. It's a memory address, and C has a special type for memory address, and it's called a pointer. And all this is just the data type that is stored at that memory address, so it's an integer, and then an asterisk. Now, this is a pointer to number. So, one more thing, this is the third thing, a dereference. Right now, number is a pointer variable, so what's stored in here is not 0, it's the memory address of where this 0 is stored. And we don't want to change the memory address, we want to change the value at that memory address. And to do that, we put the asterisk at the start, so this dereferences it, this goes into that place in memory and changes it. So now how it works out is that this and this refer to exactly the same thing, and this can be tested practically. If we run the program, the value of number is now 46. And once again, this is not useful for this case. No one will ever do this in real programming. However, it's extremely useful for other things. Namely, we can use the string copy function. So a string in C is just an array of characters, and arrays, we generally, in languages like JavaScript or Python, in which they're not even called arrays in those languages, we think of them as this abstract concept of just a listing of different values, and we have no idea what they actually do or what they look like. And in C, we have an idea of what they look like. So there's a function called string copy, strcpy, and we're gonna look in the Linux programmer manual, and we can see it's defined in string.h. So let's add include string.h into our program. Now we're gonna keep this just because why not. And how do we make a string in C? Well, there are different ways. The first, I'm gonna show you I'm just gonna create a buffer, right? And a buffer of type character, which with 100 elements in it. So this is able to store a string of 100 characters. Basically, that's all this is. And right now the buffer is empty, so it's initialized to just be all zeros. There's a string copy function. You can see these asterisk operators are all over the place in the C documentation, so you can actually understand the C documentation if you know them. No. And also it's C convention to declare all variables at the top of a function. Just keep that in mind. No. So string copy, strcpy. And this is unrestricted copy, so it will just copy into the destination. This is my epic string, the new line. It will copy all of this into the buffer. strn copy, which is also in the manual, copies just a certain size, so we can limit it to say 100 characters if we don't want to cause the buffer overflow, which, as you can guess, is when buffer overflows and overwrites memory, which is not good. And alright, so we copy the string into the buffer, and now we can print out the buffer. So just inside the buffer, and %s to print a string, and we pass in the buffer. And don't worry if the whole buffer isn't filled. As soon as it hits a null byte, which is just a 0, it will stop printing. Alright, inside the buffer, this is my epic string, and we have 2 new lines actually, so like that. Very simple. But alas, we didn't. What did we do here? So remember how we pass in a reference number into the change value function to change the actual value of the number variable? Well, this is a buffer. And just like number, it's just a load of values stored in memory, one after the other, indexed by the square bracket syntax. We didn't pass in a reference to buffer. Why not? Well, this is because a buffer and a pointer are exactly the same thing. Now, your mind is blown, I know. However, it is true. And I'll prove this right now. In fact, I'll create a char string, a char pointer string, and I'll equate this to wow pointer string and we're gonna print this out. And just on its own. Wow pointer string. See, exactly the same thing. Array and pointer, except what this did is it just it points to memory. Now, how this actually works, why this even works, it's very intuitive. So if you think about it, it's very intuitive. What does a character pointer do? It points to a single character, and in a string it points to the first character in the string. In an array, the characters are always stored one after the other, or the elements are always stored one after the other in memory. So obviously, if the first character is stored at memory address, say 67, the second one is stored at address 68, the third one at 69, the fourth at 70, and so on. And all we need to do to access the next character is add a 1 to the actual pointer or the memory address. It's that easy. And what about an array? Well, it starts at the 0th character, it goes to the 1st and 2nd and 3rd and 4th and 5th. Except we just access them with different syntax, with square bracket syntax, and not pointer syntax. So let's prove this. Printf, and we'll do character, and we'll do a little life hack here. Alright, so I'm not gonna annotate this. I'm just gonna put 2 new lines after this, and then C and 1 new line. And what this does is it just prints a character, and then it prints another character. That's what the C operator is. Character. Now, so we can access the. Alright, let's not do the 0th character. Let's do the 5th. And remember, arrays are 0 index, so this is actually the 6th character. And so that will be printed first. And what's the 6th character? It's 1, 2, 3, 4. So it's a P. It's a P. Or no, it's not a P, because that's the wrong string. It is 1, 2, 3. It's an I, right? The 5th or the 6th character of the buffer is an I. The first letter of is. In string, right? This is gonna be string. So remember, string is a memory address. It's the memory address of the first W of the string. And if we print it, right? If we pass in the memory address of a character, it will print out the character and every single character after that until it hits a 0. In the buffer, we specify that we want to print only the 6th or the character index 5. In the string, we specify the memory address of the first character, which C interprets as we want to print the whole string. If we add a 1 to the pointer, what will happen? Will it print the 2nd character? No. Yeah, alright, that's just a warning because we're printing out a string. Now, if we do string plus 1, right? It wants correct format character, wait. So the point is, it's not gonna print the 2nd character, right? It's gonna print this, right? It's gonna omit the first because it's seek to plus 1, and then it just kept printing all this. We don't want that. We want to print the 2nd character, and we dereference string plus 1, and just put the whole thing in brackets. And now we need to correct format parameter here. Boom. Now this printed the 2nd character, and it makes a lot of sense because we're adding 1 onto the memory address, which means essentially what it's doing is it has the memory address of this. Now it's at the memory address of this, and dereferences it so it actually gets the thing stored at the memory address, which is an A. So this is equivalent to an array, right? It's the same thing. It's the same concept but different syntax. So that's memory in C. Very simple concept. Don't let people say that, oh, memory is complicated. No, it's very easy. And this video should show you everything you need to know about statically allocated memory. The next video I will show you how to use the heap, which is dynamically allocated memory, and that's even cooler than this. Alright, I'll see you later. Peace out.